It's 2. All right, so whoever comes after this point, I'm going to have to get them around the 15-minute mark. Let me go ahead and share my screen. Start the broadcast, and let's start here. Okay. This is fine. Actually, I'm going to add a page. Okay, that's fine. All right. Let's do this real quick because I can tell. Let's try to throw a hissy fit. Okay, that's better. Okay. So welcome, scholars. Let's see. So we are at the end of week 7, right? So what that means, we can anticipate exam 2 to become available this upcoming Sunday at 11:11 a.m. It'll be due the following Sunday at 11:59 p.m. Sunday night going into Monday morning. I'll do the best I can to wait until after exam 2 is due before I calculate midterm grades. So this is College Algebra 2. Basically, your midterm grade, I'll take we've had 2 exams and then a whole bunch of homework and quizzes. So what I'll do is, I'll scale your exam average so that it's worth 80% of your grade. Your homework average is going to be worth 10%, and your quiz average is going to be worth 10%. I don't want you guys to stress too much about attendance. Again, the minimal that I need from everybody is just to come to the session, like get into the Zoom and just check in, right? So once you get into the Zoom, you kind of hear whatever announcements, you've gotten your attendance credit. I usually take attendance right at the start of class. Like if class starts at 1, I start taking attendance right about 1 o'clock. So the recommendation is you want to be in the waiting room maybe 5 minutes before the start of class, because after that first wave, I don't check it again until about the 15-minute mark. Sometimes I get distracted and I forget, and sometimes it turns to 20 minutes, right? But if you're in the waiting room and you feel like you've missed that first wave, you just kind of have to wait it out until I check again. I don't check again generally until about the 15-minute mark. Sometimes I try not to do it earlier, and sometimes it goes late. If you've didn't get credit for a day or so, as long as you kind of you keep checking in and you're getting your assignment submitted, then so far I've been kind of marking people as excused. I haven't really been making too big a deal. I don't want attendance to be something that stops somebody that's trying to finish, right? So that's so that you're not in a weird position just try to get your credit every day. But again, I personally try not to make attendance be the reason. Like if somebody's actively doing their work, submitting their assignments, engaging, emailing, picking their presence down, so far I've been marking people as excused. All right, so just if you know that you may have missed one or something like that, just remind me towards the end of class and we can take a look at it. Let me see if there's anything else. I think those are actually the main announcements. Also, I think that this upcoming Monday and Tuesday is fall break. I got to check my records and see if it is. I'll probably send an announcement. The stuff on Pearson is still going to be due like normal, but we probably won't do the live session on Monday if it's fall break, right? Okay. So with that, I think on Monday we went through as much of the lecture together as we could. If you want to see the end of that lecture, again, I did all the lectures in advance, so there's a recording available. You know how to find it. It's on my channel. It's usually in the description of each video. So today I want to take some time and get through as many homework questions as we can. So this is the end of chapter 3. Exam 2, you can anticipate it to be pretty much about chapter 3. So here we're asked to solve for x. So again, I'll check attendance for anybody that's late at about a 15-minute mark. So let me take some notes on this one. Let's see. Come on, why is that not working? There it is. Okay, that's And again, as usual, this is remote asynchronous. So if you've gotten your attendance credit for today, you're not obligated to stay. I think I'm saying that more so to just remind myself, like, hey, that was the agreement. So if people don't want to stay, That's on them. There was something else I was going to say, but that's okay.
Oh, excuse me?
But come on.
Okay. Excuse me?
Yeah.
Professor, did you say we've had 2 exams already?
Exam 2 will become available this upcoming Sunday.
Okay, all right.
Yeah. Okay. And as usual, another reminder is typically my exams have a prerequisite. I think it's set for either 50% or 70% on the corresponding quizzes. It might be 70%. I think I raised it a little bit, but each quiz is like 5 questions. So before you can access exam 2, I think you need to make at least 70% on the corresponding quizzes, right? I think that's how that goes. Okay. So here we're asked to solve for x. This comes to section 3.4, question number 1 from the back of that section. And we have this exponential equation in the form of 2x equals 64. Okay. So I think when we did this in class, we got them the 2 exponential expressions with the same base. We tried to get them to the same base. So it looks like we can write 64. 64 is what? 8 times 8. So is that 2 to the power of 6? 64 should be 2 to the power of 6. So then once you get both expressions to be an exponent with the same base, then you can just equate the exponents. So then x equals 6. Okay. Let's go like this. Come on. Copy. Okay. All right, so then let's hop back. Here, we got A, we got a 2 to we got 6. Let's go settings off. We got 6. Okay, let's go to the next one. All right, yeah, let's write this out. Just getting a copy. And I like to include the question ID, so that way if you're ever referencing this in like the future, you know where it's coming from, right? So it's not just like a random question, you know, like where to find it in the text. Okay, let's go about here. That's good. All right. I personally like to start with a copy of the original. So we have 4 to the power of absolute value of x equals 8, right? So what we were doing before was getting these to be the same base, exponents with the same base. So this is going to be the same as 2 squared to the power of absolute value of x equals 2 to the power of 3. Okay, so then when we say 1 power raised to another power, then we multiply. So I think in the previous example, once we had the same base, then we just equated the exponents, right? And so a power to another power, we multiply. So then this is going to be the same as 2 times the absolute value of x equals 3. Let's divide both sides by 2. Absolute value of x equals 3/2. So then from here, there are 2 results that's going to give us 3/2. Basically, it's x equals 3/2 or x equals negative 3/2. Right? And with something like this, we can check before we submit, right? I mean, I know we're doing everything remote, but let's see right here. Right, we can check this before we submit it, Rush. Okay. So in my y equals, I'm going to hit 4 to the power of, now absolute value is under math. If I go over to number, and it's number 1, absolute right there. 4 to the power of absolute value of x. Okay. So then I'm going to call on a function. I'm going to click variables. I'm going to go to my y variables. I'm going to click number 1 for function, and number 1 again, because that's what replaced our function. And so we're saying that when x is 3/2, the output should be 8. And then also when x is a negative 3/2, the output is 8. Okay, so we checked it. We confirmed that these two numbers work in the original. I guess it would help if we box our final answer. So that one, and this one. Okay. All right. So right here. And that needs to be full screen. Come on. That's the best you can do. Why are you behaving like that? Oh, no. All right. So then let's do, like, there it is. Okay. Okay, so commas to separate. So we got 3/2. So 3 by 2. Okay, what's this one? Nope. This one? Nope. This one. 3rd time's a charm. There we go. Comma. Negative 3 by 2. All right, it's cooking now. Okay, and as usual, just stop me if anything is not clear. Let me take a moment. Let me take a moment to check if we got any stragglers. Let me see. So we got a few. Okay. So, thank you. Let's see. Oh, there it is. It's 1, 2. I'm going to ask him because I don't know. Okay, I found her. Quincy, what's your last name?
Gordon. I'm about to change it for you.
Okay, I found it. Thank you. Gordon. Okay. All right. And let me check the chat. No, we haven't had it. Exam 2 will become available this upcoming Sunday. So this is the last of the new material before exam 2. I'll share my screen. So I'm under the impression that, Monday is fall break. So, I had to confirm that that's indeed the case. I more than likely will send an announcement, but exam 2 will already be available. So that means that Wednesday, I'm just going to be on the call just for answering questions. How do we get to the next part? Save. Okay, let's just keep going. But that's next time. Okay. All right. The following equation involves a single log. Solve the equation. Yeah, let's take some notes here. So let's get a copy. From here. Okay. Let's take this. Come on. Here. Awesome. Okay. Come on. All right. And right here. Okay. So we're asked to solve this equation. Let's see. So let me start by getting a copy. We have this log base 1024 x equals a negative 3 by 5. Okay, so let's use the technique of rewriting this log as an exponential. So this log equation in exponential form, we're going to swing the base to the other side. Okay, And then so when we do this, this will give us x equals 1024 to the power of a negative 3/5. Okay. So then what I'm going to do, I'm just going to put this in my calculator just for the sake of time. So I'm going to do 1024 to the power of negative 3/5. Okay. Let's say math is a fraction. Okay, I got 1/64. So then here, this one, we got 1/64. Here we go. Let's see if I close this out. Oh, I think if I just power cycle this. Let's see if that works. Man, how did I fix that last time? Turn this off again. Let me hop over here. Okay, turn it on again. See, it's working here. That works. So then if I click here, there it is. See, yeah, 1/64. So temperamental. Anyway. All right. Okay, let's go into the next question. Same kind of deal, right? Log base 5. Well, let me just get a copy because I might want the question later. Come on. So we have log base 5 of the absolute value of x equals 3. All right, again, let's write this log as an exponential. So then that's going to give us the absolute value of x equals 5 to the power of 3. What is that? 125. So then x equals basically plus or minus 125. Okay. Oh, yeah. Okay. Yeah. We got plus or minus 125. So let's do 125 comma negative 125. Okay. Okay, so this one, notice that the 23, we can't get that to a base of 3, right? I think 23 is the prime number. So this one, we would take the natural log on both sides, right? Then that's going to give us x natural log of 3 equals natural log of 23. So then long story short, if I need to write it out, I will. But this one should be the natural log of 23. If I need to write it out, just let me know. Divided by the natural log of 3. Right? I took the natural log on both sides. When you take the log, it allows you to, the thing that's in the exponent, to move it down in front of the log. So then I had x times the log of 3 equals the log of 23. Divide both sides by the log of 3. And then that's where this log of 23 divided by the log of 3 comes from. Type an integer or decimal around the 4 decimal places. okay, 854. So 2.854. Oh, come on. You still doing this thing? Why? I don't understand. I say you're working in there. Is it that I have to leave and come back? Okay. All right. I think I just got to leave and come back. Okay. Yeah, we're going to definitely write this one out. And let's make it a little bit bigger. That's fine. That looks weird. Let me delete this. It's better. I think it's fine where it is, to be honest. Okay, let me start by getting a copy. So we got this 3 times 4 to the power of 2x minus 1, and then plus 4 equals 14. Okay. So what I'm going to do, I'm just going to move items away from my variable, step by step, right? So I'm going to work my way from the furthest most item, this 4. So the inverse operation of plus 4 is I'm going to subtract 4 on both sides. All right, so I'm going to say minus 4 and minus 4. This adds to 0. Okay. So then that leaves us with 3 times 4. Come on, thank you. 3 times 4 to the power of 2x minus 1. And we have 10 on the other side. So next, I'm going to move the 3. The inverse of multiplication is division. And that's going to give us 4 to the power of 2x minus 1, 10 over 3. I'm trying to keep it as exact as possible to the end. Next, I want to get this out of the exponent. So what I'm going to do is take the natural log on both sides. So natural log of this, natural log of this. This allows me to bring this exponent down. Okay. And I'm going to go ahead and divide by the natural log of 4. So then that'll give us 2x minus 1 equals the natural log of 10 by 3 divided by the natural log of 4. Okay. I'm going to add 1 to both sides and then multiply by 1/2. Okay. So if I add 1, that's going to give me log of 10 by 3, log of 4, plus 1. But then when I multiply by the 1/2, basically we're going to have a 2 here. And this 1 is going to turn into a 1/2. Okay, I'm just trying to minimize, all the extra writing. This should be the exact result. And let's see what the instructions say. So it says approximately, right? Do not round into the final answer, then round to 3 decimal places. Okay. So then we can work it out here. Clear? So then we have the log of 10 by 3 divided by parentheses 2 times the log of 4, close off the denominator, and we got plus 1/2. Okay. So I kept it as exact as I could until the very end. And let's see. Let me zoom out some. All right. Okay. So then I'm going to go ahead and hit enter. It says 3 decimal places. So we have 0.9342. That 2 tells us to stay the same. So it's 0.934. Okay. All right. Let me just check Zoom really quickly. We'll go to the next question. So there's a question that says, what's the midterm again? That's not really a midterm, it's just exam 2. Right? That's just exam 2. It's going to be available this Sunday. Okay. All right. So let's work on the next one. Okay, yeah, let's get this one a go. So I'll get a copy. Right there. Right here. Okay. All right, keep doing this. Here, let's just actually just want to move that up. Okay. 1, 2. Let's do one more. Okay. I guess I could leave it there. That should be fine there. Okay. So we're asked to solve this equation, this exponential equation. Okay. So let's start by getting a copy. We have this 2 times 4 to the power of x minus 2 equals 5 to the power of x plus 2. Okay. So if we move that 2 to the other side, that's not really going to help us, right? So I think there's something we can do where we can go ahead and get these variables out of the exponent, right? So namely, let's go ahead and take the natural log on both sides. So we take the natural log of the entire left-hand side. What we do on one side, we also have to do on the other. So take the natural log on the entire right-hand side. Now on the left, we have to apply a few rules. Oh, sorry, guys. Yeah, I realized. Okay, we left off here, right? So we had 2 times 4 to the power of x minus 2 equals 5 to the power of x plus 2. So, again, moving the 2 wasn't going to help us, so we went on and took the log on both sides. So now we have to apply a couple of rules at once. We have the product rule and the power rule, right? When we apply the product rule, that's going to make it the left-hand side natural log of 2. The log of the product is the same as the sum of the logs, so it's going to be natural log of 2 plus, I'm going to go ahead and apply the power rule. It's going to be this x minus 2 times the natural log of 4. And if we apply the power rule on the right, that's going to be x plus 2 times the log of 5. Okay. I think that step was the most challenging in this example. So then distribute this guy. These are just numbers that I'm distributing, all right? Multiplication over addition. So this will give us the log of 2 plus x log of 4 minus 2 log of 4 equals x log 5 plus 2 log 5, okay? So then from here, let's group all the terms that have x, right? So let's see, so here's one x, here's another. So every term that has an x, we're gonna get them together. And the other terms, we're gonna move them to the right. So if it has an x, it's coming to the left. If it doesn't have an x, it's going to the right. And so, for instance, if I move this x log 5, I would subtract x log 5 on both sides. All right, so those are unlike terms. So I'm just gonna keep them separate, right? And I want to move these constants to the right. So that's gonna involve 2 plus the log of 4. Let's choose a different color here. Let's choose this, right? Okay, and then we also need to add subtract this log of 2 on both sides. Okay. Now we have a lot of unlike terms. Let me see. This cancels. This adds to 0. And this adds to 0, right? Okay. So then let's see. If we account for these changes, let me see. On the left, we have x log 4 minus x log 5 equals, we got this 2 log 5 plus 2 log 4 minus log 2, okay? So now each term on the left has an x, so we can factor out those x's or reverse distribute. So then we're gonna have x times the log of 4 minus the log of 5. The right-hand side, I'm essentially just leaving it as is. We could probably condense it, but I'm gonna just leave it. 2 log 5 plus 2 log 4 minus log 2, okay? So then ultimately we get x equals, now on top we have 2 log 5 plus 2 log 4 minus log 2. And on bottom, we have log 4 minus log 5, okay? Let me see the time. So let's see, what do the instructions say? Do not round into the final answer, then round to 3 decimal places. Okay. So let's give it a go. Okay. So on top, we have 2 log 5 plus 2 log 4 minus log 2. Okay. So this closes off the top. Then we're going to say divided by, the bottom is log 4 minus log 5. Close off the denominator. 3 decimal places. 7439. That 9 tells us we need to round up. So 744. Negative 23.744. Come on. Negative 23.744. Let's cross our fingers. Okay. Okay. I think I'm going to do one more, and then I think I'm going to call it a day. Okay. Sure, why not? Let me think about it. Okay. Yeah. So let's start. Let's start by getting a copy of this guy. This will definitely be the last one for today. So I am feeling the bird. All right. So here, that. Let's drop it here. Actually, we can leave it there. Okay, let's wait. Okay. Let's start by getting a copy of the original. So we have this 9 to the power of x minus 12 times 3 to the power of x plus 32 equals 0. Okay. So I think we came across something like this in class. We use this technique called U substitution, right? So this 9 we can rewrite as 3 squared. So long story short, we can rewrite that first term as 3 to the power of x squared minus 12 times 3 to the power of x. Let me go like this, plus 32 equals 0, right? And I think we chose style, that color. Actually, we chose that color last time. Okay. So now let's do this part. We're gonna say let u equal 3 to the power of x. Okay. So then that above line transforms into u squared minus 12 times u plus 32. Okay. So at this point, we should be able to factor, right, into some form like this, u and u. The plus means our two signs are the same. This tells me, this first one tells me that the larger number is negative, right? So if they're the same and the larger is negative, then that means that they're both negative. We're looking for two numbers that multiply to give us 32 and add to give us 12. So now what I'm going to do for that, I'm going to go through this list. Instead of guessing the check, I'm going to exhaust all the possibilities. So if I think about 32, right? 32 is what? 16 times 2, so 2 to the power of 5. 1, 2, 3, 4, 5. Okay. So I'm going to look at all the factors that generate 32 and stop at the line that adds up to 12, negative 12. Okay. So then 1 and 32, but that adds up to 33, so that's a no. So then 2, now if we've used 1, 2, we have 4 remaining, so that's 16. That adds up to 18, so that's not what we're looking for, so let's keep going. Notice there's no 3 here, all right? There's no 3, but there is a 4. We can do 4. All right, so 4 means we've used these first set of 2s. So that means we have 3 2s left over, so that's 8. And notice that 8 plus 4 is positive 12. That's close, but it's not exact. So we're just going to flip the signs, negative 4 and negative 8. These are those two numbers that we're looking for. So then negative 4 and negative 8. Okay. So then if we keep going, so then long story short, we get that u equals 4 or u equals 8, but then now we need to put u back. So then we say 3 to the power of x equals 4 or 3 to the power of x equals 8. Take the log on both sides and divide. X equals the log of 4 divided by the log of 3, or x equals the log of 8 divided by the log of 3. Okay, those are exact, and then let's put it in the proper form, this question, and call it a day. It says do not round into the final answer, then round to 3 decimal places. Okay. I do not remember, so let's just do this. Clear. Log of 4 divided by the log of 3. We get this. And then we had the log of 8 divided by the log of 3. We get this. Okay. So then I'm going to hop back here. Separate your answers. Okay. Now I didn't check these. I probably should have checked them in the original, but I'm just submitting it. So 3 decimal places, 2618. The 8 tells us to round up to 262. So 1.226. Oh, I was doing that thing. Okay. That works. This. Okay, so it's still there. Why is it there? 1. There it is. 1.262. And then we have 8927. The 7 tells us to round up. So we have 1.893. 1.893. Okay. Cross our fingers. All right, guys, that was an adventure. All right, that's a true adventure. There should be questions, but I understand if you don't want to ask any right now, it's all good. I know this is a little bit of a stretch, but if I can do it, you can do it. I know you're just being introduced to this, but I'm just showing you that it's possible. You got to find a way. All right, you have to find a way. I do encourage you all to work together. I do encourage you all to work with the tutors. Right. Again, you've already paid for the tutors; it's included in your tuition. Right. If possible, my recommendation is try to get ahead. Remember, all the homework and all the quizzes are already available for the entire semester, including the corresponding live presentations are already pre-recorded, right? So you can actually get ahead. You don't have to wait on me. Only thing you will be waiting on are the exams. For instance, exam 2 becomes available just this upcoming Sunday at 11 a.m., right? Okay. Are there any questions? I'm gonna go ahead and send a copy of this so you can pull these. If I go, this is a fall, thank you. College Algebra 2. Homework questions. Let's put it in the notes. Updated daily. Yeah, let's just put it there to be consistent. It's in the box, okay. All right, so while this loads, if there aren't any burning questions, we're going to end the session here. From one beautiful mind to another, enjoy the rest of your day. Yes, go ahead.
There was you said talk to you about the attendance thing at the end of class or whatever.
What's your last name?
Omakanya.
Okay. Were you like? What happened with Were you late?
I emailed you about it. I was like in the waiting room, but I never got put in. I don't know why. I think I forget what date it is.
Don't worry about it. Again, the best practice is just. I think I replied to it. It's just you want to be in the waiting room about 5 minutes before class starts. So like if class starts at 1, I usually start taking attendance like right at 1. I'll do the first wave, whoever catches, like whoever I see in that first wave. And then I'll kind of start the stream. I'll check it one more time immediately. And then I start class. And then I don't check it again until about the 15-minute mark, but sometimes I'm late. So, and if you miss that 15-minute mark, then, so I only check it like twice. So the best practice is try to get into the waiting room 5 minutes before the class. I went on to mark you as excused, so I don't want you to worry about that. Because I do recognize you. I know that you've been coming. So I just try to get into the waiting room 5 minutes before the start of class. And as long as you kind of keep submitting your stuff on Pearson and just keep checking in, it should be fine. Okay. All right. Are there any other questions, guys? Again, so like I want to say this upcoming Monday, I think it's fall break. If it is, I'll confirm and I'll communicate via announcement. And so if it is fall break, we won't meet on Monday. And then on Wednesday, exam 2 will still be going on. So I'm just going to get on the call and just be available for questions. Okay. All right. On that note, we're going to end the session here. And from one beautiful mind to another, take care and enjoy the rest of your day. Take care. Peace.
Have a good day.
Thank you, Prof.